A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was reading through the intelligence briefs this morning, and it really strikes me how much the conversation has shifted. For years, the focus was on what Iran was buying or smuggling in. But today's prompt from Daniel is about the shift toward indigenous mass production and those specific manufacturing bottlenecks that Prime Minister Netanyahu highlighted recently. It feels like we've moved past the era of the reverse-engineered kit and into something much more industrial and, frankly, more difficult to track.
Herman Poppleberry here, and you are hitting on the exact pivot point that the intelligence community is scrambling to quantify. The traditional model was the North Korean pipeline, where you could basically count the crates coming off a ship or a plane. But what Netanyahu brought to light regarding these clandestine underground nodes suggests a decentralized manufacturing philosophy. It is not just about one big factory at Parchin anymore. It is about a modular network where the sum is greater than the parts, and that makes the calculus for regional defense systems like the Iron Dome or Arrow 3 much more complicated.
It sounds like they are trying to solve for the target on their back. If you have one massive facility, it is easy to monitor via satellite or, if necessary, to neutralize. But if you break that production line into 20 smaller underground cells, you create a targeting nightmare. Is this a genuine leap in their industrial capacity? Or is this just a way to hide the fact that they are still struggling with the same old technical hurdles?
It is a bit of both, but the scale is what should worry people. We saw reports in February 2026 suggesting a 15% increase in solid fuel propellant output at the Parchin facility alone. When you scale that across multiple hidden sites, you are looking at a throughput that allows for a different kind of warfare. They are moving away from the legacy liquid fuel systems, like the old Scud variants or the early Shahab missiles, and moving toward the Kheibar class. The difference there is not just range, it is the readiness.
Right, because liquid fuel is a logistical nightmare. You have to fuel the missile right before launch, which takes hours and makes you a sitting duck for preemptive strikes. Solid fuel is basically a giant Roman candle. You pull it out of the silo or off the truck, and it is ready to go in minutes. But I've always heard that mixing that propellant is the real bottleneck. You can't just stir it in a bucket.
The chemistry is incredibly temperamental. You are dealing with a mixture of ammonium perchlorate as the oxidizer and a binder like hydroxyl-terminated polybutadiene or HTPB. The challenge is not just the recipe, it is the consistency. If you get a single air bubble or a crack in that fuel grain, the surface area of the burn increases exponentially the moment you ignite it. Instead of a controlled thrust, the whole casing overpressurizes and the missile turns into an expensive firework on the launch pad.
So, when Netanyahu talks about these clandestine manufacturing nodes, he is likely talking about the places where they are actually casting these fuel grains. That requires specialized equipment, like vacuum mixers and high-precision curing ovens. You can't exactly hide the heat signature of a massive curing oven in a basement without some serious engineering.
That is where the underground nature of these sites comes in. They are using the natural thermal insulation of the Earth to mask those signatures. And what is interesting is the modularity. They have developed a way to transport these precast segments and assemble them on site. This connects back to what we discussed in episode 918 regarding strategic depth. By decentralizing the casting process, they ensure that even if a major site like Parchin is taken offline, the smaller nodes can keep churning out components.
It is a clever way to bypass the use it or lose it dilemma. If your production is decentralized, your deterrent stays credible even under heavy pressure. But I wonder about the quality control. If you are making parts in 20 different basements, how do you ensure that the guidance system from Workshop A actually talks to the motor from Workshop B?
That is the primary bottleneck right now, especially with the newer iterations like the Fado 2. The Islamic Revolutionary Guard Corps is claiming hypersonic capabilities, which requires an incredible level of precision. Guidance system miniaturization is the hurdle they are hitting. They can make the big dumb rockets all day long, but getting a maneuverable reentry vehicle to survive the heat of Mach 5 Plus while still taking commands from a localized processor is a different league of engineering.
I have always been skeptical of those hypersonic claims. It feels like a lot of marketing for the domestic audience. Are we seeing actual telemetry that suggests the Fata 2 is doing what they say it is? Or is it just a high-speed ballistic trajectory that they are slapping a fancy label on?
The telemetry is fuzzy, but the intent is clear. They are aiming for what is called a maneuvering reentry vehicle, or MARV. Even if it is not a true hypersonic glide vehicle in the way the United States or China defines it, a missile that can shift its path in the terminal phase is a nightmare for interceptors. It breaks the predictable parabolic arc that systems like the Patriot are designed to calculate.
And that leads to a massive second-order effect on regional defense. If Iran can produce these in high volume, they don't even need them to be perfect. They just need to overwhelm the interceptor to target ratio. If it costs Israel or the United States $3 million to fire an interceptor at a missile that cost Iran $50,000 to build, the math eventually breaks the defender.
The cost-per-intercept ratio is the silent killer in this arms race. We saw this during the escalations last year. When you have hundreds of projectiles in the air, the defense system has to make split-second decisions on what to engage. If Iran can maintain a hot production line despite cyber sabotage and supply chain sanctions, they can essentially bleed the regional defense budgets dry just by forcing them to use up their inventory.
You mentioned cyber sabotage. I remember hearing about the Stuxnet days, but surely they have hardened their system since then. Is the production line still vulnerable to that kind of digital friction, or have they moved their industrial controllers entirely off-grid?
They have gone to great lengths to air-gap their critical infrastructure, but no system is truly isolated. The vulnerability now is in the supply chain for dual-use components. They still need high-grade carbon fiber for the motor casings to keep the weight down. They still need high-end guidance chips and specialized aluminum alloys. Those things have to come from somewhere, and that is where the friction happens.
It is like a game of whack-a-mole. You block one front company in Dubai, and 3 more pop up in Southeast Asia. But even with those leaks, isn't there a limit to how much high-grade material they can get? You can't just buy a ton of aerospace-grade carbon fiber on the open market without raising some red flags.
They have become masters of the gray market. They will set up a shell company that claims to be manufacturing high-end sporting goods or medical equipment, buy the materials, and then divert them to the missile program. But you are right, there is a limit. The intelligence suggests that while they have scaled the volume of their older systems, the production of the high-end stuff, the ones with the miniaturized guidance systems, is still relatively slow.
Which brings us back to Netanyahu's point. If the goal is to stop the program, you have to go after those manufacturing nodes, not just the launch sites. But if they are buried deep underground, as we have seen with some of the mountain bases, even modern bunker busters have their limits. There is a misconception that underground means invulnerable, but it also means trapped. If you collapse the entrance to a mountain facility, it doesn't matter how many missiles are inside, they aren't going anywhere.
True, but the Iranians know that. They have built multiple redundant exits and integrated the facilities into the local civilian infrastructure in some cases, which creates a massive ethical and political hurdle for any strike. It is the human shield strategy applied to industrial manufacturing.
It feels like we are seeing a shift in the Iranian strategic doctrine. In the past, it was about having a few big sticks to wave around. Now, it is about having a seemingly infinite supply of smaller, capable sticks. If you look back at episode 7017, we talked about the evolution from the Scud-B to the modern era. Back then, the accuracy was measured in kilometers. Now, we are talking about circular error probable in the tens of meters.
The leap in precision is what makes the mass production so dangerous. 1,000 inaccurate missiles is a nuisance. 1,000 precision-guided missiles is a decapitation threat. They can target specific hangars at an air base or specific valves at a desalination plant. That level of specificity changes the deterrent calculus entirely.
So, what is the actual health of the program right now? If we look at the industrial imports, which you suggested is a better metric than counting finished missiles, what are the numbers telling us?
The numbers are trending upward for dual-use electronics. We are seeing a significant influx of high-frequency signal processing units that are officially designated for civilian telecommunications, but are perfect for missile guidance. Also, the import of specialized resins used in composite manufacturing has remained steady despite the increased sanctions. This suggests that their procurement networks are more resilient than people want to admit.
It is frustrating because it feels like the international community is playing a game of catch-up. We are sanctioning the finished product while the raw materials are still flowing through the cracks. If I am an analyst looking at this, I am not looking at the missile parades in Tehran. I am looking at the shipping manifests in the South China Sea.
That is where the real story is. And it is not just about the hardware, it is about the human capital. They have an entire generation of engineers who have been trained under the pressure of sanctions. They have learned how to innovate with limited resources, which in some ways makes their engineering more robust. They don't rely on the same fragile supply chains that a Western manufacturer might.
I can see you getting excited about the engineering side of this, Herman, but let's look at the flip side. If their production is as robust as they claim, why haven't we seen them export these systems more widely? We see the drones everywhere, but the ballistic missiles seem to stay closer to home.
That is changing. We have seen reports of missile technology transfers to various proxy groups, though the full ballistic systems are harder to hide. The drones are the gateway drug. Once you have integrated the drone communication and guidance systems, moving up to short-range ballistic missiles is the logical next step. It is about building a standardized ecosystem of weaponry across the entire region.
It is a terrifying prospect. If you are sitting in a target zone, the idea that a non-state actor could have access to a decentralized, modular missile system that is being fed by a clandestine production network in Iran. It makes the traditional concept of border security almost obsolete.
It forces a shift toward a more proactive defense. You can't just wait for the launch. You have to understand the industrial life cycle of the weapon. That is why the intelligence Netanyahu shared is so critical. It is an attempt to map the nervous system of the program, not just the muscles.
I want to go back to the solid fuel mixing for a second because it is such a fascinating technical hurdle. You mentioned the risk of air bubbles. How do they actually solve that? Is it just better machinery, or is there a chemical trick to it?
It is mostly about the vacuum mixing process. You have to pull all the air out of the slurry while it is being agitated, and you have to do it at a very specific temperature. If it is too hot, the binder starts to cure before it is fully mixed. If it is too cold, it is too viscous to pour into the motor casing. It is like trying to bake a cake that is the size of a school bus, where if you underbeat the eggs, the whole kitchen explodes.
That is a vivid image. It also explains why they are so protective of these sites. A single person with a screwdriver could do more damage to a mixing facility than a squadron of fighter jets if they knew where to poke.
And that is why cyber sabotage remains a constant threat. If you can subtly alter the temperature sensors in a curing oven by just 2 or 3 degrees, you can ruin an entire batch of fuel without anyone knowing until the missile fails to launch 6 months later. It is the ultimate form of industrial friction.
It is a high-stakes game of cat and mouse. But looking at the remainder of 2026, where do you see this going? Are we going to see a breakthrough in the hypersonic claims? Or is the focus going to stay on this mass production of mid-tier systems?
I think the volume is the story for 2026. They want to reach a point where their inventory is so large that any attempt to neutralize it would require a conflict of such scale that no one is willing to start it. It is the ultimate insurance policy. The hypersonic stuff is the shiny object to keep people distracted, but the real threat is the thousands of precision-guided solid fuel missiles sitting in those underground nodes.
It is about creating a reality where the cost of action is always higher than the cost of inaction. It is a classic move, but they are doing it with 21st century industrial techniques. It makes you realize that the old maps of where the threats are located are becoming less and less relevant. The threat is in a basement, in a tunnel, or in a modular segment on the back of a nondescript truck.
One thing we haven't touched on is the role of foreign actors in providing the technical expertise for these clandestine sites. While the manufacturing is indigenous, the blueprints and the specialized tooling often have a foreign pedigree. We are seeing more and more evidence of cross-pollination between the Iranian program and other actors who are looking to bypass the Western-led global order.
It is a coalition of the sanctioned. They are sharing the lessons learned on how to keep a production line running when the world is trying to shut you down. It is a parallel industrial world that operates outside the lines of the World Trade Organization and international treaties.
And that is why tracking industrial imports is so vital. If you see a sudden spike in the import of high-precision ball bearings or specialized lubricants, you can bet it is not for a new line of bicycles. It is the lifeblood of the missile program.
So, for our listeners who want to get into the weeds on this, what should they be looking for? Because the headlines are always going to focus on the big explosions or the political rhetoric.
I would tell them to look at the dual-use export control lists. When a country like Iran starts complaining about sanctions on specific industrial chemicals or electronic components, that is usually a sign that you have hit a nerve. Also, keep an eye on the commercial satellite imagery of known industrial zones. You won't see the missiles, but you will see the changes in power consumption, the new ventilation shafts, and the increased security perimeters.
It is about reading the negative space. You look for what they are trying to hide, not what they are showing off. We have some technical breakdowns of missile telemetry and white papers on the solid fuel transition over at myweirdprompts.com if people want to see the actual math behind the burn rates we were talking about.
I highly recommend those. Once you see the physics of it, you realize why these production bottlenecks are so hard to overcome. It is not just a matter of throwing more money at the problem, you have to respect the chemistry.
And the chemistry is a harsh mistress. Before we wrap up, I want to circle back to the Fatah 2 one more time. If it is not a true hypersonic glide vehicle, what is the most likely scenario for its actual performance?
It is likely a high-speed maneuvering re-entry vehicle that uses small thrusters or aerodynamic fins to make minor course corrections in the final seconds of flight. It is enough to dodge a localized interceptor, but it is not the world-ending superweapon the propaganda suggests. However, in the context of a mass launch, even that limited maneuverability is a massive force multiplier.
It is about the cumulative effect. One fancy missile is a problem, but 500 slightly above average missiles is a catastrophe. It really puts the recent intelligence claims into perspective. It is not about a single smoking gun, it is about an entire smoking factory floor.
I mean, that is the core of the issue. The factory floor is the new front line.
You almost said the forbidden word there, Herman. I saw you catch yourself.
I have no idea what you are talking about. I was simply emphasizing the centrality of the manufacturing process.
Sure you were. Anyway, this has been a deep dive into a topic that I think is going to define a lot of the geopolitical tension for the rest of the year. The shift from importing to indigenous mass production is a genie that you can't really put back in the bottle.
It requires a total rethink of how we approach non-proliferation. The old tools are becoming less effective every day.
Well, on that cheerful note, I think we have covered the ground Daniel laid out for us. It is a sobering look at the industrial reality of modern conflict.
It is, but knowledge is the first step in building a defense. You have to understand the machine if you want to know how to stop it.
True enough. Big thanks to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes.
And a huge thank you to Modal for providing the GPU credits that power this show. We literally couldn't do this deep dive analysis without that compute.
If you found this technical breakdown useful, a quick review on your podcast app really helps us reach more people who are interested in the substance behind the headlines.
This has been My Weird Prompts. We will be back soon with another deep dive into whatever Daniel throws our way.
Catch you later.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts.